I can divide whole numbers using models and strategies. 3 digits divided by 1 digit is what we're going to show today. We're going to consider the problem 411 divided by 3 equals, we're trying to figure that out. I know that the number that I start with is my dividend, divided into my groups will be my divisor, and the answer to a division problem is a quotient. The first thing I'm going to do is find 411. Here I have 1, 2, 3, 400, 10, plus 1, 411. I'm going to use the fair share strategy. Now I know that 411 divided by 3 means that I have to make 3 large circles because my divisor tells me I need 3. So the first question I ask myself is, do I have enough for each circle to have one of my biggest chunk? And I do. I have 300. So I'm going to give each one a fair share. 100, 200, 300. Now I start again with what's left over. Do I have enough for each group to have another 100? And I don't. So I'm going to have to go to the trading place. I'm going to trade my 100 for 10 tens. And you can see that they match perfectly. So I'm going to trade that in. So now I can break those apart and ask myself that question. Do I have enough for each group to have another 1? I do. 10, 20, 30. Do I have enough for each group to have another 1? I do. 10, 20, 30. Do I have enough for each group to have another 1? I do. So when I broke up my 100 into 10 tens, now I was able to give each one a fair share. Do I have enough for each group to have another 1? I don't. So I'm going to have to go to the trading place and trade these in. So I'm going to give up 1 of my 10s and get 10 ones. I'm going to give up another 1 of my 10s, just do them all at the same time, and trade that in for another 10 ones. So now I have 10, 20, 1. Do I have enough for each group to have another fair share? Now, I see this big chunk. I know there's 21, and I know that 21 divided by 3 equals 7. So I'm going to use a shortcut. If I didn't know that, I could sort each one out. 1, 2, 3. Do I have enough for each group to have another 1? I do. But I know that 7's going to fit, so I'm going to finish that. 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So how many do I have in this group? I have 100 plus 30 plus 7. I have 137. I wonder how many I have in this group. 100 plus 30 plus 7. It's the same amount, 137. How many do I have in this group? 100 plus 30 plus 7. They each have an equal share of 137. So my quotient is 137. The next way that I can solve this is using place value. I'm going to start with my 411. And this time, I'm going to sort them in a different way that looks a little more mathematical. So I'm going to put my division sign, and I'm going to use 1, 2, 3 for my divisor. Now I'm going to do the same thing that I did with fair shares, but this looks a little bit more like you would do in 3rd, 4th, and 5th grade. Do I have enough for each group to have 1? I do. Here is my 400. Here's my first 100, my second 100, and my third 100. Do I have enough for each group to have another 1? I don't, so I'm going to have to trade it again. I'm going to trade it in for 10 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to check it in my trading place And I know that 10 tens equals 100. So I'm going to break those apart and ask myself this question. Do I have enough for each group? I'm going to think in chunks this time. So I think that I can count 3, 6, 9, and I know that I can use 9 tens. So I have 30, 40, 50, 60, 70, 80, 90. Now I have a problem. I have 21 left, and it doesn't fit equally into my groups, and so I'm going to have to trade. I should have 21. Here's my 2 tens and my 1 from my original problem. So I'm going to see, do I have enough for each group to have 1? I'm going to think in threes this time. 3, 6, 9. Do I have enough for each group to have another one? I'm going to do another 3. That group has 6. The second group has 6. And the third group has 6. And look, do I have enough for each group to have another one? Perfect. 1, 2, 3. So how many do I have in this group? I have 100 plus 30 plus 7. This group has 137. 137. This group has 137. And this group has 137. It's the same as fair share. Now, I can do it another way without using my place value blocks because I understand them now, so I can just draw them out. So I'm going to start again with 3 groups. And I know my target number is 411. So I'm going to ask myself this question. Do I have enough for each group to have 100? Yes, I do. And I know that I can draw hundreds as boxes. I have just used 300. I have 111 left. So I have to think, do I have enough for each group to have another 100? And I don't. So I'm going to have to count by tens this time. 10, 20, 30. Not close. I'm going to keep going. 40, 50, 60. Not close. I'm going to keep going. 70, 80, 90. Ooh, that's pretty close. Could I go again? 100, 110, 120. Nope, that's too big. So I'm going to have to settle for my 90. So I'm going to subtract my 90, and I have 21 left. So I go back and ask myself this question. Do I have enough for each group to have 1? I did my hundreds and my tens, now my ones. I do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. All done. So how many do I have in each group? I just used them all up. I have 100 plus 30 plus 7. This group has 137. This group has 137. And this group has 137. My quotient is 137. Solved it several different ways. Now I have the same quotient. Now, this is the way that 4th graders are supposed to be able to do it, and you'll notice that it's much, much faster. So we want to use the most efficient method. I'm going to start with my 411 dividend in the center of my problem and my divisor of 3 on the outside. So I notice that I have a 4 in the hundreds, a 1 in the tens, and a 1 in the ones. So I'm going to ask myself this question. If I'm going to be counting in groups of 3 and I'm thinking about 3s, I want to try as close to 400 as I can, so I'm going to think in hundreds. So I'm going to think 3 times 100 equals 300. That's pretty close. If I had 2, 3 times 200, that's 600. That is way too big. So I'm going to back off. I'm going to use my 100. Since that's the answer, I'm going to put it on my quotient line, 100. When I counted 100 3 times, I used up 300. And since division is repeated subtraction, I'm going to keep taking it out. So 411 minus 300 gives me 111. Now, I know that the 100 is too big, so I'm going to have to start thinking smaller. I'm going to think in tens now. 3 times 10 equals 30. Way too small. 3 times 20 equals 60. Getting there. 3 times 30 equals 90. Almost there. 3 times 40, no, that's way too big. So I'm going to back off, and I'm going with 3 times 30. I'm going to write my 30 on the quotient line, but I'm going to organize it above my tens. So I'm going to write 30 on the quotient line. Now, when I subtract out my 90 that I just counted, I have 21 in the ones left. So now I'm thinking, back to my 3, I'm thinking threes. How many threes can I count to get to 21? I know that's a fact, family, but I'm just going to double check it. 3 times 1 equals 3. 3 times 2 equals 6. 3 times 3 equals 9. 3 times 4 equals 12. 3 times 5 equals 15. 3 times 6 equals 18. And there it is. 3 times 7 equals 21. And since I hit the target, I'm done. I have to remember to put my 7 on my quotient line. Since it's in the ones place, I'm going to organize it. And 7 times 3 is 21. Division is repeated subtraction. It leaves me with a remainder of 0. Now let's add these up. 100 plus 30 plus 7 equals 137. I solved it a different way, and I got 137 as my quotient. Now let's model the algorithm. When I use the algorithm, it's just the mathematical shortcut, but you shouldn't use the algorithm if you don't understand why it works. So when we're done, we're going to compare these two models. So I'm going to start with my 411 as my dividend on the inside, and I'm going to put my 3 as the divisor on the outside. So now I'm thinking a little bit differently, but I'm still thinking in threes. Do I have enough for each group to have 1? I already know from doing my partial quotient that I can pull 3 out of 4 in the hundreds one time. 1 times 3 is 3. And I'm going to organize that. Remember, we think in the Tom method. I'm going to think about it, I'm going to organize it, and then I'm going to do my math. I know that 1 in the hundreds times 3 times 3 is going to give me a 3 in the hundreds. 4 minus 3 in the hundreds is 1. 1 is smaller than 3, so I can continue. I'm going to bring down my tens, which gives me a new number of 11 in the tens place. And it starts all over again. Think threes. How many threes can I pull out of that 11 in the tens place? 3, 6, 9. That one's pretty simple. I'm going to write a 3 above the tens place. And what did I count to? I counted 3 times 3 equals 9. Let's subtract that out because division is repeated subtraction. And 11 minus 9 is 2. So now I have a 2 in my tens place. See how organized that is? Since 2 is smaller than 3, I can keep going. I'm going to bring down the next one, and my new number is 21 in the ones place. So I'm going to come back and think in my threes. How many threes can I pull out of that 21? I know that 7 times 3 is 21, and so I'm going to finish my fact family. I'm going to organize my math by putting my 7 in the ones place on the quotient line. 7 times 3 is 21. Finish it out, and I have a remainder of 0. That means that 411 divided into 3 groups gives me a quotient of 137. I just got 137 a different way. I am pretty mathematically confident that the quotient is 137. Now, let's look at how the partial quotient and the algorithm are the same. What do you see here? 411 divided by 3. When I did my hundreds, when I put my hundreds into 3 equal groups, look, I have 300 here. This 3 is in the hundreds. That means it actually means 300. When I subtracted, I got 11 in the tens. Now, when I brought this down, that actually means I had 111 there. I took out my 90. Here's my 90. Matches. When I was left with my 21 and my 21, and it still had a remainder of 0. The partial quotient works because it's the same as the algorithm. It's just that you're not putting all of your powers of 10. That's how we know that we can divide whole numbers using models and strategies to get a quotient.